today. I feel like I'm the Irish delegation ringing in our Eurovision Song Contest score here when it's done remotely by TV. I was hoping to be there, but unfortunately the air is next 48 hours due to this terrible storm that we've got hitting the country. We actually had about 3 to 4 foot of snow last night, and we haven't had snow like that in Ireland for the last 36 years, so it's an incredible weather event. Now, so Jana reduced because we don't want to delay your lunch today, so I had 2 options here. I could reduce the number of slides in half or talk twice as fast. So what I've actually done is cut my slides down by half. So if you want the full presentation, don't hesitate to contact Jan and myself, and we'll be more than happy to share the full presentation here with you. So this presentation is about 15 minutes long, and it talks about our journey as we migrated all of our clients to Neural MT, or certainly the majority of our enterprise clients. So how did we do it? Well, it was kind of a 3 to 4 step process. Step 1 was we had to obviously have a neural technology integrated into the heart of our platform. The second step was to prove to our clients that NMT was better than SMT. And then the third one was then to measure the impact of that migration from all of our large clients from SMT systems to NMT, and then obviously celebrate the success of that with the development team in Kantan, but also with our clients as well. So what did we do in terms of introducing Neural to our platform, the Kantan platform? Well, believe it or not, we started looking at Neural MT back in November 2016, and we built the first of Neural MT on the platform, which is based in the Mathis. And we developed 12 language pairs. So we spent about 3 to 4 months building 12 language pairs. And we did actually release that, and people could use, our clients rather, could use that prototype to start experimenting with neural-based MT. But there was a lot of problems with our original prototype, one of which was the training time. The training time for a typical engine, the average size engine in our platform is about 100 million words in terms of size. And the training time for a 100 million word source word NMT engine was about 4 to 5 weeks. Okay, so that was clearly a very cumbersome process. So we migrated then to OpenNMT in January 2017. I think we were one of the first to download the SDK and start working with it. And we launched Kantan Neural, which was based on OpenNMT, in March 2017. And at the same time, we developed 39 language pairs. So we had 39 language pairs ready to go from the day we launched the actual product. We now have in excess of, I think it's 54 languages or something like that at the moment. But we also had to change a lot of our other technology on the platform to support Neural MT. So in other words, we have this interactive development environment called Build Analytics, Kantan Build Analytics, and we had to remodel that to introduce support for perplexity scores, because there is a degradation in the accuracy of BLEU and TER and F-measure scores when you move to neural systems. And perplexity is a score that we're using now to give us a prediction of how the engine is going to produce good quality translation. So we actually modified that. And you can see on the right-hand side there, the last graph at the bottom of the screen is how we actually display perplexity scores for our clients. So we can display perplexity scores at a segment level, and we look at those segments that have high perplexity scores and analyze how we can improve the engine by analyzing those scores. And we also have to change Kantan LQR. Kantan LQR stands for Language Quality Review. It's a portal, it's a platform that's built into our technology that allows our clients to run full MQM, multidimensional quality matrix projects on the output of machine translation systems, be them statistical or neural. And I have to say, that was probably one of the key technologies that we had to develop in order to accelerate the migration of our clients from SMT to NMT, because the very first thing they asked us to do was to prove that it would produce better translation. They couldn't take that for granted. We had to prove. We had very large production systems working with some of the biggest companies in the world, and we had to prove to them that NMT would outperform NMT, and that's what LQR was designed to do. It gives you a great way of actually testing the quality of machine translation systems. And the really cool feature in there is that once you aggregate and collect all the feedback from professional translators, there's literally a big red button on the user interface that you click, and it automatically adapts the NMT system based on the feedback from the translators. So you have continuous rapid improvement of engines. Now, other notable milestones that we had to achieve during last year, which was really our formative year in embracing NMT technology, was we had to support terminology. So we introduced level 1 terminology support in April. We had full support for tags and places, which goes beyond what the current Open NMT toolkit provides. And then we built an adaptation layer so that instead of taking on about 4 days now to train a 100 million word engine. So if you have 100 million words, it takes approximately 4 days to build an Open NMT engine on that. And that's because we throw lots and lots of computing power at it. Well, if you adapt an engine, it takes about 4 hours. So we've actually gone in the last year from a 4-week training time to a 4-day training time to a 4-hour adaptation time. So we can pretty much adapt engines within a working day. And that's made an awful huge difference to the experience of using. And obviously there's a list of some of the languages that we've launched as part of the initial release, and you can see all the blue and tear scores and F-measure scores there, and the size of those engines as well. So we track all that information very thoroughly on our platform. There's the changes that we made from LQR to start tracking the quality of translation. So that was the first thing so they were embedding technologies to empower ourselves and our clients to start embracing Neural MT. But then we had to prove the hype, because remember, if you go back to March, April of last year, there was all sorts of papers going around talking about how cool NMT was, that SMT is dead, and there was an awful lot of papers that said it was like, so different, it was approaching human levels of human quality levels of fluency. So we had to prove that hype by using hard facts with our clients. Again, our clients are some of the biggest companies in the world. They're just not going to migrate to a new technology until you can go in with a report that says this engine will perform much better according to the following factors if you switch to NMT. We've got to really scientifically do that. So how did we do that? Well, in fact, we set up 3 experiments, probably some of the biggest experiments in NMT time. And what we did was, guys, because our platform can build statistical systems as well as neural-based systems, we said, okay, well, let's build identical engines. Let's take the same training data set. Let's take the same reference set. Let's use the same automated scores and build NMT engines. Okay? So if we do that, we can now compare apples with apples, because they're identical engines except for the training process. So one is done with deep learning, the other one was done with probability-based statistical systems. So what we had was now is apples and apples, and we were able to compare those engines very accurately to see how they performed, okay? And this really deviated from a lot of the white papers that were in the industry at the time, because there was nobody really comparing the same engines. They were taking a neural engine from, say Google Translate, and comparing it with an engine that they had built themselves in an academic lab or maybe in a commercial environment. And of course, those 2 engines were totally dissimilar to each other. They didn't have the same training data. They didn't have the same level of training and vocabulary in there. So really those results diverged. You couldn't really make an honest assessment of the quality there. By approaching it the way we approached it, there is no difference to the engines other than one is NMT and the other one is SMT. It's identical training data from that point onwards. So what we did was we chose 5 languages, and we put 3 professional translators, all native speakers in these languages. We chose those languages, guys, on the screen very selectively. So we chose languages that were relatively high scoring for statistical systems and languages that were relatively challenging for statistical systems. So we didn't take all the easy languages and say, look how good NMT is. We took a spectrum of both easy and hard languages. So German is a difficult language for SMT, particularly with word placement. So particularly with verbs, it travels a long distance during the decoding process. So we wanted to really see if NMT solved that one problem. If you look at languages like Spanish and Italian, or maybe gender-based languages like those, you've got in-word agreement problems with statistical systems. So we wanted to see if neural-based systems solve those problems. So there was quite a lot of thought went into these languages to see how they perform. So there's your word counts, the number of segments. So they're not small engines here. You know, they were all around 50 to 100 million words. Interesting there is the UWC, the unique word counts. So we wanted to make sure that each of these engines had a very large vocabulary. And that gives us a good level of testability when we test it with professional translators. It also reduces the number of out-of-vocabulary words, obviously, for an assessment point of view. And they're the domains that we chose as well. So we chose those domains, guys, because it's relatively easy to get training data in those domains. It's all publicly available. So why did we choose publicly available data that's accessible? Well, because we wanted people to repeat this experiment with their own system to prove our results. So there's nothing proprietary here in terms of the data. So we built the engines anyway, guys. Now here's a very elaborate spreadsheet here. There's lots of kind of numbers here. I'm not going to dwell on any particular set of numbers. But basically what we did was we used F measure as an indicator of an automated score, as an indicator of vocabulary, depth and support. We used blue for an indicator of fluency. We used tear for a prediction of most likely post-editing effort. And then you can see we threw in the perplexity scores there on the second last column on the right-hand side, okay, just to give you a sense of how good perplexity is at predicting quality. So if you graph those engines at the bottom, so you can see we have German, Chinese, Japanese, Italian, and Spanish. If we graph it, let's just focus in on one data set, guys. Forget about the other data sets. It's just too much to condense in one presentation here. But if you look at the blue score, now blue is probably the most well-known, probably most debated. I will put forward that it's probably the most liked in academia for measuring fluency. But if you look at the scores, guys, not a single one of our NMT engines beat the engine in terms of the blue score. At all times, all of our SMT engines had a better blue score. Now, that one insight caused us a bit of grief, it has to be said, because if you have read any paper last year before, say, August of last year, they would always talk about blue being better in NMT engines. We did not see that, guys. When we built our engines with the same same training sets, we actually had our SMT engines outperforming us across the board with no exception on blue. And we're seeing that across all of our clients today. When they convert an SMT system to an NMT system, blue is a bit of a disappointment, it has to be said. It's not really a good indicator of translation quality from NMT engines. We then used KantanLQR to run these assessments. This is a part of our platform. It's actually built into our platform. And this gives us the ability to automatically distribute projects to translators. All they do is log into a web portal, and the translation is available for assessment on the screen. It's kind of a really nice user interface. It's like a post-editing environment, but it's designed specifically for language assessment. We use the MQM framework to collate the feedback from the translators. Translators, 3 per language, okay? So the reason we use 3 translators is because if you use 2, you can't really find outliers in your data set. If you use 3, you can get some correlation between 2 and you can identify outliers. So we're very specific in how we approach the entire process. And ultimately what we wanted to do is ask them, how do you rank NMT output versus SMT output. Which is better? That's the binary decision that all this experimentation led up to. So what's the results? Well, if you look at the ranking, so remember what we do with professional translators is we display a source text, which was in English in all cases, and then we displayed two possible translations, one SMT system and an NMT system, and we asked them to rank which was better. Now, in some situations, the translation could be the same. So if you look at these graphs here, that's what these orange graphs tell me. So for instance, for English and Chinese, 37% of the segments were deemed equivalent by the professional translators. In English and German, 13%. English to Italian is 24%, Spanish 10%, and so on. If you look at the extreme right-hand side of the graph, guys, you'll see that we have a number there, 21, and that's all is the average of all the 5 languages in one column. Okay, so that's what that 6th column is on this graph. So on average, 21% of segments in our test, and we tested the engine, by the way, on 500 segments. Okay, 500 segments were tested here. So 21% were deemed to be the same. So about 100 segments were deemed to be the same between SMT and NMT. So how did SMT fare out? Well, I'm going to superimpose the SMT scores there. You can see in Chinese it was 20%, Japanese was 21%, German 34%. On average, 25% of segments were deemed to be better from Moses-based SMT systems. Okay, again, the systems were designed the same. But look what happens, guys, now when we superimpose NMT. Now remember, before I give you this big reveal here, none of these NMT engines outperformed the SMT engines in the calculation of blue. None of them did. Our SMT engines all scored blue. But look what happens when I throw in the Neural MT. Suddenly, it has just changed the landscape. And that's the impact that OpenNMT has had in our client base. It has fundamentally changed how they see automated translation today. It's not just a time improvement, it's a huge improvement in quality. And what we're seeing there is there's kind of 3 categories of errors that have almost been eliminated overnight. And we've been trying to solve these errors for years, decades, with statistical systems, one of which is inter-word agreement. If you've got gender-based languages, you see a tremendous drop in inter-word disagreement. So you get all those kind of gendered spelling, noun and adjective spellings correct. You get fantastic fluency because we understand the construct of the sentence now with neural-based systems. We're finding that in German, the verb is pretty much always in the correct place. And that's a big improvement over our statistical systems. And you know what, guys? We didn't have to put an awful lot of effort into solving those problems. We just used OpenNMT. And we had lots of technology on the statistical side to try and solve those problems for our clients. So we proved by doing this, by the way, we produced 2 white papers on these results, and these white papers are available. We presented them at AMTA and EMTA and so on. And we're now doing a 3rd white paper to talk about classification of errors and how errors have in NMT versus SMT. And we're going to be producing that paper later on in the year at the European Machine Translation Association. So, how did we measure the impact? Well, guys, the impact has been phenomenal on our platform. If you look at the number of engines and the number of words that we're translating, so there's the number of words over the last 4 quarters on the Kantan platform. So last quarter we did 3.4 billion words of translation. But look at the breakdown of engines. Moses-based SMT engines currently represents about 78% of our entire population engines. We have 1,000 engines on the Kantan platform today. 78% of those are Moses. And in the last year, 28% moved up to Kantan Neural. So in 1 year, we have had a fifth of our engines migrate to neural-based MT. Okay, so you can see there's a huge migration. And if you look at the clients that aren't doing that migration, it's all the big guys. It's eBay, It's Amazon moved all their engines over to neural-based systems. It's Vistaprint. It's Transperfect. All the big companies are making this leap straight away, move to NMT systems. If you look at the top 20 NMT languages, there they are in ranked format there. So our top engines are English, French, followed by English, Spanish, English, German, English, Italian. Then we're into Japanese and so on. Then we're reversing the language arcs there to do German, English, French, English, and so on. And that's the full top 20 languages for NMT on our platform today. We track all these stats. We've got stats coming out of our gazebos from our. If you look at the top source languages, look at all the engines that we're building here. This is ranked by the number of translated words. So, you know, last year 3.8 billion words were translated with engines with English source data. And then you can see the number of translated words quite rapidly there. And then if you look at the number of engines with the target language, sense of where the real activity is in machine translation across the industry, and languages people are really focusing on. You know, you'd be surprised to hear we support was it 65 or 66 languages? I can't remember the number off the top of my head here. And believe it or not, the top 7 or 8 languages represents in excess of 80% of the volume that's going through our system. So even though we have, like, you know, 50 odd different language combinations available in NMT, the real activity is really the top 20% of those languages are delivering about 80% of the word volumes for our clients. And of course, step 4, guys, was to celebrate the success. And that's what we did. So we actually held KantanMT. We brought a number of our clients together and we explained how they can optimize the use of NMT and to improve their language quality. So thank you very much, guys. I hope I didn't go too fast. I was given 15 minutes. I think, John, I've made close enough 15 minutes. So thank you very much. And again, my apologies that I couldn't make it today, but I'm actually stranded in my kitchen for the last 2 days because I can't even leave my house, so much snow out there. But this opportunity.